All right, this is the last one I'm going to do together with you guys, actually. And I'm going to say, again, we have a couple of angles. We can't really combine them. So we're going to have to use this. And it's nice to know that we have 3 different versions of this. Ultimately, we want to end up with an equation that we can work with, which means it'll be like factorable or all in terms of one trig function. So I can see that I'm going to replace this cosine of 2x with one of these expressions, but I want to choose the one that will make the rest of my job easier. So since this particular equation also has a cosine in it, this is probably the best, not probably, this is the best version to use. I'm going to replace cosine of 2 theta with 2 cosine squared theta minus 1. And then of course we have minus cosine of x. Oh wait, I'm sorry, those should be x's. But you know what I meant. And then that's it. Now it's all review stuff. So I'm going to write this in standard form and think of it as if it were a quadratic. I'm thinking of it the same way I would think of 2a squared minus a minus 1. This I would factor into 2a and 1 and 1, and this would be negative and this would be positive. So I'm going to have 2 times the cosine of x plus 1, cosine of x minus 1, both equal to 0. If I set these both equal to 0, I'm going to end up finding that the cosine of x either equals negative 1/2 or the cosine of x equals positive 1. And I'm going to think very carefully about the unit circle. This is the horizontal component being negative 1/2, so that's a short side on the x-axis. So that gives me these 2 pi over 3 reference angles. So x is either 2 pi over 3 or 4 pi over 3, just shy of pi or just more than pi. And then for the cosine of x equaling 1, that happens right here at 0. And those are all my answers between 0 and 2 pi, but I had to start by getting everything as a cosine of the same type of angle by deploying this specific version of this double angle formula. Unlike the sine one, you won't ever really, it's rarely helpful to take one of these and write it in this form. You know, like I'll never see this. If I ever saw this in an equation, I wouldn't bother replacing it with cosine 2 theta. I would just work that problem, you know. But when you see sine and cosine butted up against each other like this, that's a good tell that you have to probably use a double angle formula to go the other way. So good luck with this. Not every time, but you know, you have to consider it. It's fun. Lots of challenges ahead. Let's enjoy them. So try the rest of these problems on your own. They are due on Wednesday. And then I have some other fun announcements that I'm going to put on Classroom. I'll see you guys soon.